Number 1. Your experiment output as well as a quick run through on what you did on the experiment. So basically, this experiment is kind of a continuation of the previous one, where we worked with transfer functions, poles, and zeros. But this time, the main focus is understanding how the locations of the poles affect the stability of the system. So I started by expressing the system in terms of its transfer function, which is the ratio of the Laplace transform of the output over the input. From there, I identified the numerator and the denominator polynomials and used them to determine the zeros and poles of the systems. After finding such poles and zeros manually, I plotted them on the complex plane through a pole zero plot. Then I analyzed whether the system is stable or not based on where the poles are located, specifically if they are on the left half, right half, or along the imaginary axis. I was also given multiple transfer functions where I had to determine such poles and zeros, classify their stability, and verify the answers using MATLAB. Additionally, I used MATLAB to generate the impulse responses and observe how the system behaves over time. Number 2. Discussion on the challenges in performing the experiment or understanding the concepts. So in terms of challenges, the computations for me are somewhat manageable since they involve concepts like solving the roots, which I'm already somewhat familiar with. However, the more challenging part for me was interpreting the results, especially understanding how the pole locations directly relate to the system's behavior and stability. At first, it was a bit confusing for me to connect the mathematical results to the actual response of the system, but through plotting and observing the impulse responses in MATLAB, I was able to somewhat better visualize and understand these relationships. Number 3. Notes to self or anything worth noting. So one thing I really noticed is how important the poles locations are. From what I've seen, complex poles introduce oscillations and the real and imaginary parts affect how fast these responses decay and how frequent the oscillations are. Also, I realized that stability is directly seen in the time response. If the output settles over time, the system is stable. But if it keeps increasing or doesn't settle at all, then the system is unstable. Overall, this experiment helped me understand the stability that isn't just theoretical. It's something you can actually see in the system through how it behaves over time. That would be all.